Very good morning, one and all. My name is T. Rajita, lecturer in ECE, Government Polytechnic, Mamla. So, in this third semester, I am dealing with network analysis. Now, I am going to discuss the topic identification of mesh circuits, identification of mesh currents. So, in the last class, we discussed two general methods of network analysis. So, what are they? One is Kirchhoff's voltage law, another is Kirchhoff's current law. So, one is mesh current loop method, that is based on KVL. That is Kirchhoff's voltage law. What is that called? Kirchhoff's voltage law? In a Kirchhoff's voltage law, the algebraic sum of all the voltages in a closed loop is equal to 0. That is loop current method or mesh current method, that is based on KVL. And it can be applied to only a planar networks. It cannot be applied to all the networks. It can be applied to only planar networks. So based on this Kirchhoff's voltage law, we can use in network analysis mesh equations method, mesh analysis. And the second method is node voltage method. Mesh current method, and second one is the node voltage method. This node voltage method is depends on based on the Kirchhoff's current law. What is that Kirchhoff's current law? In already last class we discussed that Kirchhoff's current law is the algebraic sum of the currents in a junction or at a node is equal to 0. That means the current entering into the node and the current entering into the or leaving from the node is equal to same. Once again I am repeating, this Kirchhoff's law states that the current entering into the node and current leaving from the node are equal. So, based on this Kirchhoff's current law, we are using node voltage analysis method. And this node voltage method can be applied to any network. So, now I am going to discuss these two methods and by using with the help of Kirchhoff voltage law and Kirchhoff current law. So, just I am refreshing the last class. What is a loop and what is a branch and what is the mesh and node. So, loop. Loop is a set of branches forming a closed path which passes through no node more than once. So, in a loop, a set of branches forming a closed path which passes through no node more than once. A closed path. What is closed path? A closed path which originates from a particular node terminating at the same node, traveling through various other nodes without traveling through any node twice. That is the closed path. Mesh. A loop which does not contain any other loop or loops within it. Okay? In this, only one loop should be there. There should not be more loops. So, branch. A part of network which connects various points of the network with one another. A part of network which connects various points of the network with one another. That is node. A point at which two or more elements are joined together. A junction. A point of network at which three or more branches are joined together is called a junction. So on completion of this period, you would be able to know to identify the mesh currents, determine the number of mesh equations required to solve a given network. See this figure? In this figure, there is a 11 branches and 5 nodes. 11 branches and 5 nodes. See here, this set of 4 branches constitute neither a path nor a loop. What are the set of 4 branches? See here, these 4 branches D, E, F, G, it cannot be form a path or a loop because this is not a closed. So, a closed loop itself it form a loop or mesh. So, these set of 4 branches constitutes neither a path nor a loop. See in this figure, and this set of branches does not constitute a path since it is traversed only by passing through the central node twice. Here, this A, C, D, E, F, G, A, I, G, it is a closed path, but the central node the current is passing through this in twice, so that it cannot constitute a path. See again here. See in this, these two becomes a separate loops, but not a single path. See here, there is a set of branches. What are the branches? There is C, A, B, J, I, H and the voltage source. This becomes a closed path and it encloses the nodes only one time. So it constitutes a loop. This is a loop. So it may be a number of types of loops can be possible in that circuit. So I am going to discuss how many possible loops are possible in the circuit. So by considering this C, A, B, J, I, H, the voltage source, it is a closed path. So that it is a one mesh. See here another type of this thing. In this H, C, A, E, G. It is also a closed path. But there is a D is also there. But it's not a mesh because it constitutes other loops. So here there is a closed path. See here, the set of branches constitutes both the loop and mesh. And this A, C, D, E, this is a one closed loop and one mesh current. So it is the car mesh. Here another this thing GFJI. It constitutes a closed loop and it is also called as mesh. First two steps to be followed in mesh current analysis. Check whether the circuit is planar or not. Second thing, select the mesh currents. See, this is the very important to selecting the mesh currents for analyzing any circuit by using mesh current analysis. The selection of mesh currents is very important. Then once we select the mesh currents, write the KVL equations using mesh currents for each mesh. So, solving the above equations. These are the steps involved in a mesh current analysis. First, the circuit is planar or not. First, we have to check that. A circuit is said to be planar if it can be drawn on a plane surface without a crossover. A circuit is said to be planar if it can be drawn on a plane surface without a crossover. For example, this is a circuit. And this is the circuit. Here there is a circuit in class B figure. There is a crossover is there. In the first figure, there is no crossover is there. So, number of mesh equations required to solve the given network. This is the how many number of equations are required to solve the network. So, if there are B branches and N nodes, including reference node, number of nodes, N means number of nodes, and branches, number of branches is called B, and number of nodes is N in a network. Then the number of mesh current equations M is equal to B minus N minus 1. That means we are excluding this reference node. That is M equal to B minus N minus 1. So now I am going to take one example. So in this, see how many branches are there? First observe that. Tell me what is that? So here there is a 1, 2, 3, 4, 5 branches are there, and nodes are 3 nodes are there. It is identified node 1, node 2 and node 3, and node 3 is the reference node and branches are 5 branches. So by taking the formula, we can calculate the number of meshes. So the number of meshes is equal to number of branches minus number of nodes plus 1. So number of branches is 5, number of nodes is 3, and number of mesh current equations is equal to 5 minus 3 plus 1, that is 3. So here we can take a 3 number of mesh equations, and first we are identifying that mesh equations and we can solve the problem. So I am taking another example. Here there is a 1, 2, 3, 4, 5, 6 branches are there. See here, check it. 6 branches are there. That is VL2 is branch 1 and C1 is branch 2 and L1 is branch 3 and branch 4 is C2 and L3 is branch 5 and L4 R1 is branch 6. There is 6 branches are there. And what are the nodes? The L2, C1, L1 are joined together. That is node 1. And C2, L4, L1 are joined at one node. That is node 3. And L3, C3 and C1, C2 are joined at a node. That is node 2. And L3, R1, VT are joined in another node. Node 4. So how many nodes here? 4 nodes and 6 branches are there. So number of branches is 6 and number of nodes is 4. And how many number of meshes? 6 minus 4 plus 1. That is 3 mesh equations is possible and we can take 3 loop equations. So now I am going to take another example. See here. This is the figure. So in this, how many branches are there? Select that. And R3 is one branch. R4 is one branch. Branch 1, branch 2. And C3 is branch 3. C1 is branch 4. C2 is branch 5. And R1 is branch 6. R2 is branch 7, R5 is branch 8. So there are 8 branches here. And in this, how many nodes are there? R1, R3 and C1 are joined at one node, that is node 1. And C1, R4, C2 are joined at node 2. And C2, R5 and R2 is joined at node 3. And R1, R2, C3 is joined at node 4. And R3 and voltage source, R4, C3, R5 are joined at node 4. Means there are 4 number of nodes are there. 5 nodes are there, 8 branches are there. So with the reference node, with the help of that, the number of nodes is 5 and branches is 8. So how many number of equations? 8 minus 5 plus 1. So the redrawing the above circuit with crossings, without crossings. So check here again. See, this is the circuit. Again, we can by redrawing that the same thing, C3 just outside. This means it should not, it is now planar network. So by crossing, it cannot be, looks confusion. It can be confusion and we can change that. See here, there is a branch 1, 2, 3, 4, 5, 6, 7, 8 and the nodes are 5. R3, R1, R2, C1, C2, R4, R5, C3 are the 8 branches. And node 1 between R3, R1 and C1 and node 2 R4, C1, C2 and node 3 R1, R2, C3 and node 4 R2, C2, C3 and node 5 V, R4, C3, R5 are joined. So there are 5 nodes, 8 branches and the equations, mesh equations is 8 minus 5 plus 1 is equal to 4. So for solving this type of problem, we need to write 4 mesh equations and from that we have to solve the mesh currents. Once you know the current, we can calculate the voltage in any branch, any current in any branch and any element and power dissipated or voltage energy stored, whatever we want to calculate or whatever we can analyze the circuit that is possible in the circuit. So this is another circuit. Here also there is a connection is crossed. This also we can write that this is possible to write. And how many possible branches? R3, L1, V, L2, R5, R4, L3, R2, R1 means 1, 2, 3, 4, 5, 6, 7, 8, 9 branches are there. Here 9 branches are there. So how many nodes are there? The junction between R3, V and L1 is first junction R1 and L2, R1, R5 is another junction 2 and L3 and 2 short circuits is R3 is another junction and R2, L3, R1 is one junction and R4, R2 and R3 is another junction. So number of junctions are also more 1, 2, 3, 4, 5, 6 junctions and 9 branches are there. See, it's correct or not by redrawing this circuit without crossings. This is the and by without crossings I am drawing in other circuit. See here, branch 1 is R3, branch 2 voltage source and branch 3 L2 and branch 4 R5, branch 5 L1, branch 6 R1 and branch 8 R2 and branch 4, branch 7 R4 and branch 9 L1. So there is 9 branches are there. And the nodes. The junction between R3, branch 5, branch 1, branch 5, branch 2 is node 1. And the junction between branch 3 and branch 4, branch 7 and branch 6 is node 2. node 3. And the branch 5 and branch 4 and L1, that is branch 9, is connected, that is node 5. At node 5, what are the branches? See here again. These two are short circuited, and L1, R3, this L2 and R4. How many are connected? At node 5, R4 is connected, L1 is connected, R3 is connected, and L2 is connected. So these four are connected at node 5. At node 4, there is branch 6, branch 8 and L2. Like that, there is a number of branches is 9 and number of nodes is 5. The equations, mesh equations are 5. That is 9 minus 5 plus 1 is equal to 5 equations. See here, there are 5 loops are possible here and 5 meshes we can take it as. So by taking the 5 mesh equations, we can solve this problem. So in this way, we are selecting the mesh currents. So now I am taking another example. It's the easiest example. By seeing this, we can easily tell that there is a 2 meshes, and in this branch 1 is voltage source, branch 2 and is R1, branch 3 is R2, and branch 4 is R3, and branch 5 is R4. So here only 2 mesh equations is possible. 1, 2, 3, 4, 5 branches are there, and four nodes are there, and 5 minus 4 plus 1, so that there are the 4 nodes. See here, number of nodes is 4, branches is 5, and number of mesh current equations is 5 minus 4 plus 1, that is 2 equations. So it's a simple thing. By seeing that there is a 2 closed paths, and we can take it as. So the node between branch 1 and branch 2 is 1, and branch 2, branch 3, branch 4 is connected at node 2. In branch 4 and branch 5 there is node 4, and at node 3 branch 1 and branch 3 branch 5 is connected. So that is the 4 nodes are there. So 5 minus 4 plus 1 is equal to 2 mesh equations. So by taking 2 mesh equations, we can solve the. This is another example. So in this example, there is a branches. How many branches are there? Branch 1 is R1, and branch 2 is R2, and branch 1 and branch 2 is connected at node 1, and branch 2 and branch 3 and branch 5 and branch 6 is connected at node 2, and branch 5 and branch 4 is connected at node 3, branch 8 and branch 7 is connected at node 4. And R3, that is branch 3, branch 4 and branch 7 is connected. Branch 1 is also connected at node 5. So how many nodes here? 1, 2, 3, 4, 5. 5 nodes are there. How many branches are there? 8 branches are there. 1, 2, 3, 4, 5, 6, 7, 8. 8 branches are there. So 8 branches, 5 nodes. So how many are there? 8 minus 5 plus 1. 4 mesh equations are there. 8 number of nodes and number of equations is 8 minus 5 minus 1 equal to 4. This is how we are selecting the number of mesh equations. This is the method. So from this we discussed, what we understood is identifying the mesh currents, determining the number of mesh equations required to solve the given need. So the circuit is said to be planar if it can be drawn on plane surface without a crossover. It can be drawn on a plane surface with a crossover. Which one is correct? The first one, it can be drawn on a plane surface without a crossover, is called as planar network. Which of the following statements are correct? See the statements. A mesh is a loop. A loop is not always a mesh. A mesh is a loop, but loop is not a mesh. Some of the loops may be mesh, it may not be mesh. That is the answer. Answer is A. In the network with B branches and N nodes, including reference node, then to solve the network, the number of mesh equations required are given by M is equal to B minus N minus 1. B, M is equal to B minus N plus 1. C, B is equal to M minus N minus 1. Which one is correct? See, I am again repeating. M is equal to B minus N minus 1. M is equal to B minus N plus 1. B is equal to M minus N minus 1. Which one is correct? The first one is correct. M equal to B minus N minus 1. Answer is A. So take the assignment. Here I drawn a equation, circuit. From that write a number of mesh equations. So just I am explaining that, you do that. And this, how many branches are there? 1, 2, 3, 4, 5 branches are there. And how many nodes? 1, 2, 3. 5 minus 2 is 3. 3 equations are there. 3 nodes. 5 minus 3 is equal to 3. plus 1 is equal to 3 mesh equations. So second step, find the number of mesh equations for the above circuit. So note down this and how many equations is possible in this network. You can redraw this and you can take it. Number of branches. See, number of branches is 10 branches are there. How many nodes? 1, 2, 3, 4, 5, 6, 7, 8. So, how many equations are possible? 10 branches and you take the number 1, is possible would be 10 minus